This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Justin Byer for Software Engineering Radio, and today I'm speaking with Kim Carter. Kim is a technologist, information security professional, entrepreneur, and the founder of BinaryMist. He's a chapter leader of OWASP New Zealand and is also a certified Scrum Master. Kim is also a former host of Software Engineering Radio and has 20 years of commercial industry experience across many domains. Welcome to the show, Kim.
How's it going, Justin?
Hey, Kim. So just to start off the show, I kind of want to set a foundation for the audience. So today we're going to be talking about dynamic application security testing and specifically the OWASP Purpleteam project that you're working on. So to start off, can you kind of tell us what dynamic application security testing is?
Yeah, so it's a kind of black box testing. It's obviously security testing. So you've got lots of different types of testing, right? So you've got your unit testing, you've got integration testing, which generally focuses on testing the actual code. So you're actually testing the implementation of the code rather than actually testing like the interface of the software itself. A dynamic application security testing is usually coming at the software from a black box perspective, or as an end user would, but in an automated fashion.
Yeah. So when you say black box, you're referring to the concept of white box testing versus known source code versus completely unknown source code.
Yeah. So with your DAST or dynamic application security testing, you don't get a view into the source code at all. You're coming at the application from outside of it rather than looking at the code itself.
Okay, so that's how it's kind of different from a static security analysis scan, where that's looking at the actual code and saying, you know, this is a common format for an XML entity injection, or this is a common format for a SQL injection, and then kind of taking a guess. You're actually trying to say, does this actually have a SQL injection here? Yeah,
exactly. It actually is. It's putting it through the test as an end user or as an attacker would.
Okay, and just at kind of a high level, and we'll dive into some of the specifics with how the Purpleteam project actually works, but from a general perspective, how does a dynamic application security test work? You know, do I just put in my web page and say, here, go at it, or do I have to give it specific endpoints and tests to do?
Different products do things, I guess, in slightly different ways. So with Purpleteam, you create a job file or a build user config file. And in that file, basically, what we've got is we list out the routes. We list some fields of those routes. We list authentication and how to actually get to the application. Basically, just details around how to actually get to the application and how to go about testing it. There's some stuff in there like the routes and fields and also a little bit of dummy data to put into those fields for the first pass over. And basically what that's doing is giving the application tester basically just a starting point. And then from then on, it knows that those routes exist, those fields exist, and things start to get a little bit more dynamic, and it sort of like takes off on its own accord.
Okay, and we'll dive into a little bit more of the specifics of how Purpleteam works a little bit later on. But essentially what you're saying is it's almost like a cannon. You're kind of pointing it at the website and you're saying, you know, here's where I kind of want you to hit. And you're giving it some data to start off with to almost lay a foundation for it to start testing. And then the application, how that responds changes how the actual security testing application is going to try to test things. So if it sees, oh, there's these fields, let me try these different known injections that should work. And then if the application gives me a 500 error, it might try different things.
Yeah, that's pretty much it. Basically just pointing it in a general direction and giving it some tidbits to get started. Yeah.
So back on episode 453, I had spoken with Aaron Reinhardt about security chaos engineering, and we kind of discussed this concept of continuous verification. You know, the idea that you're always coming up with different scenarios which are plausible and then testing your code against those to determine if there's a regression or a known issue that you need to address. And those kinds of things. How do you think DAST or dynamic application security testing would compare to something like continuous verification? Would it be an augmentation, a replacement?
Dynamic application security testing is generally an augmentation to most of the other types of testing, like static code analysis and that sort of thing. You can't basically just say, all we're going to do is dynamic application security testing because it's it's not really enough. It doesn't give you defense in depth. In order to get defense in depth, you need lots of different types of testing because they're all going to find different things.
Exactly. They all kind of have their own strengths and weaknesses.
Yeah.
And on that matter, I mean, you kind of said that it's not going to replace it, but how do you think it compares to something like doing a penetration test on your applications?
It's actually quite similar, but it's automated. And the idea is to, at least with purpleteam, is to have it running as the developers, engineers are writing code and introducing defects. So as they're introducing defects, purpleteam is running, and then it comes up with a report, some results, and some details on, basically gives you details on where the defects are, what to use to reproduce them, and some advice on how to go about fixing them, which is quite similar to penetration testing. But the main difference is that with penetration testing, it's usually performed very late in the SDLC, like often at go live or, several months after the code's been written. And often then the developers can't even remember the specific areas that they were working on that may have introduced a specific defect. So, yeah, if you can find and fix those defects as they're being introduced, it's just so much cheaper as well.
But kind of going down this penetration testing route, so you said the difference is you're trying to catch defects early in the process versus having almost the big bang at the end where penetration test comes and they give you a 500-page report that says your application has 1,000 SQL injection vulnerabilities, 2,000 XML entity injections, and every other OWASP or MITRE common weakness enumeration in the book. But are there things that a penetration test is going to catch that dynamic application security tester isn't?
Yeah, so that's a good point. What usually happens is that developers are introducing often pretty trivial sorts of defects that penetration testers can find very easily, but the penetration testers only have a budget of, say, a week or 2 weeks to spend on the actual system under test. So what happens often is they'll come up and they'll, say, find 5 criticals, 10 highs, 10 mediums, and 10 low severity bugs. And the business decides, because it's so expensive to actually fix those defects at that point in time, well, we're only going to fix the 5 criticals. So it's super expensive and you don't get all the defects fixed. With the likes of purpleteam running over your source code daily, the idea is that you find and fix all those simple defects as they're being introduced. And even some of the more complex ones, purpleteam will tell you about. And then basically when it comes time to hand it over to the penetration testers, they're going to be able to concentrate on defects that are further up the ladder or not the lowest hanging fruit anymore. So you're basically just raising the bar considerably for the attacker because purpleteam's already found a lot of the defects. The developers have fixed it because they've been made aware that they've introduced defects like the day before or whatever. And then like the penetration testers come along and they can focus on the more gnarly sort of defects. And then some of those will get fixed as well. So you're just raising the bar considerably for the attacker.
Yeah, so the idea kind of being that penetration testing is catching, as you kind of said, the higher on the ladder, the business logic vulnerabilities where for some reason there was a weird condition where certain business logic conflicted with what the intended output was, or some higher level certificate issue or backend infrastructure issue that, it's not necessarily application level, it's the backend systems that caused an issue in the application. But can you kind of name some of the vulnerabilities that you would normally see something like purpleteam detecting?
Most defects are usually found in the application code itself. Like you mentioned, the defects can be found in infrastructure and SSL, TLS certs and that sort of thing. Purpleteam's got an application tester and it's got a TLS checker and a server checker, which is not yet implemented. They're on the backlog. So they'll be finding some of that infrastructural stuff as well.
Okay. And that might lead to a discussion later about how that might integrate with things like Terraform and more ephemeral infrastructure. But one other question I kind of had, how does dynamic application security testing and purpleteam work with distributed applications? Something that I'm deploying across 50 data centers across the world. So
because it's coming at your application from a black box perspective, it's it's seeing what an attacker is going to see. So it's attacking your application like a physical attacker would. So there's really not too much difference there. You can point it at a specific endpoint, and then it's going to find what an attacker would normally find.
Okay, so as long as my code deploys are working correctly and all my data centers are the exact same replica of the application, it should be catching everything that you would see with those kinds of things.
You could point it at several different endpoints. There's no reason why you couldn't do that.
Okay, so you could kind of almost check to make sure that all of your defects that your developers are saying are actually fixed and deployed across the entire environment versus just specific environments like a staging environment, for example.
Yeah, but in order to do that, you'd have to point it at a few different endpoints or multiple endpoints.
And then how would something like DAST compare to using things like development frameworks? I'm thinking of things like an ORM from a very high level concept where it's starting to abstract away a lot of these injection vulnerabilities. Is that kind of removing the need for dynamic application security testing, or is that actually giving more of a reason to keep doing it because now you're making this assumption that the RM took care of it? I don't need to worry about it.
Yes. Again, it comes down to a defense in depth. I mean, adding all these different frameworks and ORMs and that sort of thing, sure, the idea is that it helps to steer developers in the right direction, but then developers are still writing those ORMs and frameworks, so there often is defects in those as well. Coming at your application from a black box perspective, you'll end up finding the defects in the ORMs and frameworks as well, rather than just in the application code that the developers are writing.
Yeah, exactly. You're not only testing just your application code, but now you're testing all of these dependencies that you've also pulled into your application code because you brought in, 20 different sanitizers for the output and 50 different ORMs because your developers thought that if they added more, it would make it more safe.
Yeah, inadvertently, yeah.
Exactly. And it's that time complexity cost. Now, if I'm trying to sell this to my organization, we already have a static analysis tool. We're already paying for penetration testing. Why would I want to bring in something like a dynamic application security tester, other than in the case of it being open source in purpleteam?
Yeah, so your static code analysis is not going to find everything. It finds known defects, whereas your dynamic application security testing is going to find some of the known defects and a lot of the unknown defects as well. It's just coming at your application in a far more dynamic sense. So if all you're doing is covering your code base with static code analysis, you are not going to find all the defects. And you'll find some obvious ones in the libraries because they're dependencies and that sort of thing, but it's definitely not going to find most of the defects.
Essentially, it's just going to look for known patterns. If I think of something like, the SEML project, it's looking for specific groupings of commands in a specific language. But with DAST, does it have any limits on languages that it works with? Can I have a development shop that does JavaScript and does Golang and does Perl all under the same dynamic application security tester?
Yeah. So dynamic application security is language agnostic. It doesn't even know what language you're using because it's coming at the application from the outside.
Okay. And is there any special instrumentation that a developer would need to add into the code to make it so that a DAST could hook in some way to get feedback on the actions that it's doing?
Not normally. With purpleteam, there definitely isn't. Okay.
And what kind of overhead do you see something like a purpleteam product adding, manpower, hours, complexity? Do I need to hire someone specifically to run this? Is this something that the development team could run? Do I need a dedicated security team?
The idea of purpleteam is so that you don't need a dedicated security team. And so your development team is actually getting mentored by the tool itself. So the idea is that with purpleteam running over your applications and telling you about the defects you've introduced the day before or whenever the test was run last, the idea is that it's still fresh in your heads, the code you wrote, and the tool actually guides you along the path to fix your own defects. So it points you in the direction of where the defects are, how to reproduce them, and provides some details on how to actually fix them. So it's working as a mentor. So the idea is that you don't need to have security knowledge up front, but working with the tool actually helps you to learn more about security as well as it's finding your defects and helping you to fix them.
Okay, so the concept in education that I usually hear thrown around is, you're shortening the feedback loop for the student, or in this case, the developer, to learn from their mistakes with what they're doing. I wrote bad code on, Monday, and then on Tuesday morning when I come in, I see, hey, that was bad code. It has these issues. So now in my head, I'm always going to remember, or hopefully always remember, that writing, direct user input into a SQL call is a bad idea, and I shouldn't just concatenate strings. That ends bad.
Yeah, exactly. The other thing is that if you do it again, then the tool should find it again. And so, once you've made the same mistake several times, you're not going to make it again.
Yeah, when you get the 50th report and your boss starts asking, you're going to stop making that mistake, hopefully, or you might not have a job very long. So changing a little bit here, have you seen a big difference in the DAST space between commercial tools and open source tools? I mean, primarily, I've seen a huge amount of commercial tools in the space and very little in the open source world.
I think probably mainly because the tools are actually quite expensive to create, very time consuming because they can be quite complex. Yeah, so there's not very many tools that are actually freely available at all, purpleteam being one of them. So purpleteam's got an OWASP offering and a paid for offering. The only difference is that the paid for offering is already set up for you, so all the infrastructure is set up for you. But if you decide to use the OWASP purpleteam, which is the same code base, then you've actually got to set up all the components yourself. And that sort of takes some time. On a good run, that can take sort of like probably 2 to 3 days to set up.
Okay. And that's something where, as an organization, you're probably making that manpower hours complexity decision of build versus buy, where you're saying, is it worth standing up the open source component with what we're going to save? And it may be more of something where you're doing it as a test run or a dry run to see, is it worth the investment?
Yeah, exactly. I'm planning on having a free trial for the paid tiers anyway, so you can actually trial it without going through the motions of setting the whole thing up, spending several days setting it all up. The one thing that is common to both OWASP purpleteam and BinaryMist purpleteam, which is just my own company, is that you've still got to set up the CLI and the job file, which just tells the purpleteam backend where your application is, how to authenticate against it, and which routes you want tested, and some field information, which is usually fairly trivial.
Perfect. And we're going to discuss that a little bit later when we start diving into the OWASP purpleteam specifics, because I do want to dive into some of the brains behind purpleteam and how these job files work and the CLI works. But a couple more questions on just DAST. Have you seen it delay software releases or builds in any significant manner? Or is it really just almost, I want to say, an augmentation to, the secure code training that you send every developer to before you let them sit down and do their coding?
The best place for it is in something like a nightly build, because it can take some time depending on the size of your application. I'm sort of expecting, to allow somewhere between 15 minutes and an hour for a full sort of system test. That's more of a nightly build than a continuous integration type build.
Okay, so when I'm thinking at this from the high-level defense and depth perspective, I think static analysis tool integrated into the IDE, catching some of the lower-level known issues right off the bat. Then you have some type of continuous integration testing, which might be unit testing or some type of security chaos engineering continuous verification process that's running on each commit. And then you have your dynamic application security testing running nightly that's doing some more dynamic testing, discovering some vulnerabilities that you may not have known about. And then, you have your annual pen test in there for PCI and your annual secure development training that you're required to do because, you need the checkbox.
Yeah, that sounds like a pretty good stack.
Moving into, the specifics of the OWASP purpleteam tool, why we brought you on the show. Can you tell us just a little bit about the project as a whole? What was the inspiration for it?
The inspiration is basically just to help developers create more secure software. I did a proof of concept about 3 years ago and took it to a lot of different conferences and workshops all around the world and that sort of thing to get developer feedback and get developers actually using the proof of concept and and working out whether it was going to be something viable to take further and actually turn into something. And it seemed like it was. Developers were pretty keen on it, pretty excited about it. So what I was doing in that proof of concept was simply using OWASP Zap. I was writing some tests for it, and it was hitting Node Goat, which was it's another OWASP application. It's a purposely vulnerable node application. So I was just using that as the system under test, and basically had a single script that I was using to drive Zap with, and that was sort of the beginning of it all. And then I also had some discussions with Simon Bennett, a creator of Zap, and he was talking about writing a service that he could put Zap behind so that it was running in the cloud, but he didn't have enough bandwidth for it. So I decided to actually just jump straight into it and get started. And it just so happens that OWASP Zap is one of the emissaries.
Yeah, let's dive into that a little bit, because you use the term emissary here. What do you mean by that?
So the architecture, what we've got is we've got a CLI which sits on your build box, or is basically as close to your build as possible. And in there, the build user basically just creates a job file, which I've discussed. And then when you run the CLI, it fires that job file to the back end. If you're running locally or you're running in the cloud, there's some slight differences. If you're running in the cloud, then most of the infrastructure's in AWS, and it goes to an API gateway and a network load balancer, and we use Cognito for the authorization. If you're running locally, basically those components up front aren't there, and you're hitting the orchestrator directly. Now, the orchestrator is the first main component of the purpleteam backend, and the orchestrator basically does what the name says. It orchestrates everything. It talks to the different types of testers. At the moment, we've got the application tester, which is, it is the application tester, but our repository name is the app scanner. So we've got testers there. So we've got the application tester, which is fully implemented, and we've got the service scanner and TLS checker, which is on the to-do list. It's all architected so that these testers can be plugged in, and the community can add additional testers. Now, these testers are responsible for the emissaries. In the case of the application tester, our emissary is OWASP Zap. In the case of the service scanner, our emissary is probably going to be Nikto. In the case of our TLS checker, the emissary is probably going to be SSLIs. So the number of emissaries that are spun up is determined by the number of routes that are passed in to the back end from the CLI, and that's all defined in the job file. We've got a current maximum of 12 that may or may not be increased in the future. So the emissaries are spun up dynamically via Lambda functions. Those Lambda functions, when run locally, are hosted via SAM CLI. When they're run in AWS, they just run on AWS Lambda itself. We're using Redis as the messaging system, which sends back all the tester events to the orchestrator. The orchestrator basically puts all those events together and then sends them back to the CLI. We've got some details in the documentation around the different types of messaging that you can use to have them sent back to the CLI.
Okay, so just to kind of recap what you're talking about here, and we'll definitely link to the documentation so people can dive more into the specifics on the code if they want to. But essentially, the high-level application architecture is you have the CLI, which is on your build server or somewhere in that region. That's then taking your job files, which we're going to dive a little bit into because I have a couple more questions on that. But it's taking your job file. It's using that as almost a message, essentially, to say to the orchestrator, hey, I want you to do these 12 things. The orchestrator then takes that and uses the abstraction of a tester to say, okay, we're going to do an application test, or we're going to do a service test, or we're going to do an SSL test or TLS test. And then that's all defined in the job file, specifying what kind of testers it's doing.
Not quite. So those different testers get run no matter what. The job file simply has the routes and the fields. It doesn't say like which tester are going to be used or anything like that, because all the testers are used. Okay,
so the job file is almost a architecture overview, or a very simple architecture overview of your application. So the orchestrator seeing that and says, okay, these are the endpoints we're going to run all three of these testers against. then the testers are defining the emissaries, like you mentioned earlier, which is what's doing the actual work under the hood.
Yep. So the testers themselves are responsible for spinning up in number of emissaries, and that's dependent on how many test sessions are in the build, in the job file.
So if you have 12 jobs defined or 12 routes defined in the job, you're going to end up with 3 times 12 testers or emissaries running.
So what you've got is a sort of a hierarchical thing in your job file. You've got test sessions, and you've got routes, and then you've got the fields per route. So a test session can have any of those routes that are defined in the job file. So it may have 2 of those routes, and another test session, which is in the same job file, may have 1 route or may have 10 routes. So the idea there is we're keeping those. The reason we've got the test sessions is so that we can make sure that there's no cross-pollination happening between the testers. So it's basically just separating everything out so that we don't get overlapping results in between test sessions. Basically what defines a test session is a username and basically a set of credentials. So you can think of a test session as someone that's going to log into your application.
Okay, so a test session is almost like a login session. Yeah. But then this kind of, as you mentioned, that cross-pollination, do you see some types of overlap between, what Zap is reporting and what, or Z attack proxy is reporting in a tester for your app versus the Nikto reporting?
So the Nikto isn't implemented yet. Actually, there could be crossover between the testers, but it's pretty unlikely because Zap doesn't really touch on SSL TLS defects.
Okay, so whereas Nikto does more of that route discovery, additional endpoint discovery, and doing additional testing on those, you're not going to see that necessarily with Zap, where Zap is just doing, known MITRE common weakness enumerations.
Yeah, so the thing is each tester's got quite a different responsibility, so there shouldn't be much overlap, if any, between those testers.
Okay, and when you say, service tester with Nikto, what are you imagining that's going to pick up vulnerability-wise versus the Z attack proxy?
So it'll pick up configuration issues with how you've set your server up. Last time I looked at this was like a couple of years ago, so it's not fresh on my mind. I've been working on the application tester and the emissaries for the application tester. So the service scanner and the TLS checker are still to be implemented. Probably start on the TLS checker is probably going to be my next cab off the rank.
Okay, so we'll kind of bring you back on the show once those other testers are a little bit more fleshed out. Maybe we can discuss, your thought processes and implementation for that. But kind of going back a little bit with the job file, you were mentioning there's a limit of 12 right now that may or may not change. And I assume you put the limit in for obvious rate limiting reasons. But could you define multiple job files? If I had, 24 routes, could I define 2? Or I wanted 24 test sessions, could I define 2 job files?
Yeah, so I'll answer that first. Well, it wasn't actually a question, but I'll just discuss that first point. There was a limit of 12 simply because of the UI. Because we're using a CLI UI, watching more than 12 test sessions at once, it was just too much. It took up too much space, and that was simply the only reason. What we want to do is get hands on the tool and actually see, what people need. Do they need more than that? Is it enough? And we'll go from there. Your main question there around multiple job files. Yeah, there's no reason why you can't have multiple job files, but there may or may not be a need for it. I think what we need to do is actually get people that are using it to tell us whether they want more job files or not. Yeah, there's nothing to stop you writing multiple job files and starting a test with a different job file.
Okay, and I guess if you really examine it from the perspective of test sessions are really just credentials, there's probably not a huge amount of need to have 24 sets of credentials to test unless you have quite a lot of RBAC roles or something you want to test.
Yeah. Although I don't think there's really anything stopping users doing that, so it would be interesting to see how it actually went.
Yeah, and what their actual use case around that was and why they went that route versus a different route. But out of curiosity, is there a specific language that the job files are written in?
It's just JSON.
Okay, so it's pretty accessible to most developers then. All right, so earlier you mentioned, Redis messaging and some options around that. Can you kind of discuss how that works. We did an episode on Redis, episode 444, where we kind of discussed some of the functionality of it. But I'm curious how you're actually leveraging it in a real production app for messaging.
Yeah, so we've got a couple of different use cases here. So when you're running it locally, when you're running purpleteam locally, you can use server-sent events, which uses Redis PubSub, or we can use long polling, which uses Redis PubSub and lists. When we're running a purpleteam in the cloud, we're constrained to using long polling, which basically means we're using Redis PubSub and lists. And there's a few pros and cons to each of those, which all are documented in the purpleteam README currently on GitHub. I could go into a whole lot more details, but it starts getting quite complicated quite quickly.
So just at a high level, what are some of the trade-offs that you're going to make as a developer or as a security person setting this up if you choose, long polling versus PubSub? I assume it's response time for test completion.
So with the server-sent events, if we're using just PubSub, what that means is if the CLI goes offline, or we close the CLI and then we start it up again while the tests are still running in the back end, we can miss a section of messages that may come from the orchestrator. If we're using long polling, what happens is because we're using lists and using PubSub, we're essentially persisting the messages to Redis lists and then are using PubSub to push those messages back to the CLI. So if we're using long polling, we don't actually lose any messages when the CLI goes offline. And saying that long polling is slightly more chatty, but not a lot, because what we do is we send a request to the orchestrator, and then the orchestrator basically pops as many messages off the Redis list as currently there, and then returns those via PubSub. So it's actually not too chatty. So if you're using purpleteam locally, I'd just try using both and see which works best for you.
Okay, so essentially you're almost getting close to guaranteed delivery with the long polling versus PubSub where it's just firing it off blindly.
Yeah.
Why did you opt for Redis over a more traditional, message queuing system like RabbitMQ or Kafka or something like that?
I don't know. It seemed to be pretty easy to set up. Yeah.
So it was mainly just a ease of use for the end user when they actually went to build their infrastructure out locally.
Yeah. Well, the thing is, Redis is just running in a container, so it's just another container to deploy. There's quite a few services there, and they're all sort of deployed at once, other than the actual emissaries, which get fired up when the job file comes through.
Okay, and how does that work? I know you had mentioned a little bit earlier about some CLI that kind of works in between when you're running it locally, but how does that work when launching a Lambda job out of a container?
Yeah. So what's happening there locally is we use Docker Compose UI. So that allows our tester containers access to the local Docker socket to spin up emissary containers on the host as well. So we don't have containers running in containers or anything silly like that happening. We've just got additional containers that are spawned up using Docker Compose UI to host the emissaries. So what's happening there is the actual testers talk to SAM CLI locally, and then SAM CLI talks to Docker Compose, which has an API, and Docker Compose also has access to the local Docker socket, so it can spin up containers. In the cloud, it's just Lambda. So our ECS containers, which have our testers running in them, talk to AWS Lambda, and then AWS Lambda basically just spins up the S2 containers on demand.
Okay, so essentially, locally, you have an API abstraction to just spin up more Docker containers versus in the cloud, you're just doing an API abstraction to spin up Lambda jobs for temporary short-lived containers.
Which spin up the ECS containers, yep.
Okay. Now, we've kind of talked a lot about how this project is working under the hood and a lot about, the underlying architecture behind it. But I want to talk a little bit about the emissaries. Why did you choose to go with something like Z-Attack Proxy for the application scanner?
So OWASP Zaps is free and open source, basically, and it's a great HTTP intercepting proxy. I mean, we've got others like Burp Sweep and some other older ones, but Zap's still pretty much cutting edge. And Simon and the team are still working hard on that and just doing really well with it. I don't think it's going to be going anywhere soon.
Okay. And just from your perspective, if I'm starting a new project, let's say I'm doing, something like a progressive web app, or I've decided that I'm building a giant distributed system over the weekend, how am I going to integrate this into my new project?
Yeah, so the details for that are on purpleteam CLI README in GitHub. But basically, it's just so there's a few options there. You can spin up the purpleteam CLI so that you can see the actual interface and what's happening, or you can run it headless. We run it headless when we're putting it into a build pipeline. So yeah, there's a few different ways you can sort of set it up there, and a few different ways you can install it as well. You can install it into any type of build pipeline. I haven't come across any build pipelines that we couldn't install it into. It's language agnostic, so we're just basically spawning process. We're spawning the purpleteam CLI process and then just feeding it the job file.
Okay, and out of curiosity, what language did you end up writing purpleteam in?
Pretty much everything's in JavaScript.
Okay, so everything's pretty much in JavaScript, and that you're just injecting into the build pipeline with some type of call, I'm assuming, to the shell to call the CLI to upload the job files.
Yeah, so we just run purpleteam basically. So we just spawn purpleteam with the test command. So you can run any of its commands. It's only got about 3 or 4 of them at the moment. Test plan, status, just to check whether your back end's up and responsive, and test plan, which returns what the current test plan is going to be happening in the back end.
Okay. And let's say a developer decides they don't want to use Zap. They want to put in a burp connector. How would they do that? Would they write a whole other tester? Would they write, comparable tests that they could put into Zap to run that would meet the same needs as Burp Suite?
Yeah, so the idea would be to create a tester, and then that tester sits in a container and basically just follow suit to what's already been done with Zap. So a Zap's actually also driven with Selenium. With the application scanner, there's 2 emissaries that sit side by side there. So we've got Selenium, which basically gets the Zap requests proxied through it. So we need that in order to run active tests against your system under test. For the likes of our server scanner using Nikto or TLS checker using SSLIs, we haven't actually implemented those yet, but we think for the emissaries, there's only going to be like one. So you've got the server scanner tester, which will have the Nikto emissary, and the TLS checker, which will have the SSLIs, probably emissary.
Okay, so essentially you're using Selenium as like a headless browser for Zap to go through to hit your test endpoints. Okay, totally understand that. So, and this will probably be a silly question since kind of answered by the fact that you're using Zap, but I assume this comes with pretty much any test case you could think of out of the box?
Yeah. So what's happening there is we're running a full Zap active scan. So we've set up a bunch of things before we actually start the active scan, like different thresholds and different scanners that Zap needs to use and plugins and that sort of thing. There's a bunch of setup required before we actually tell Zap to actually do the active scan. And then once the active scan started, it goes through a plethora of tests. Those tests are listed on the Zap Proxy docs site.
Okay, so we'll link to Zap Proxy documentation and what kind of testing it supports. I assume if a developer wanted to, and this may not be a great question for you, but they could write some type of custom test if they had a weird application edge case that they wanted to check for.
So at this point in time, we don't have the ability to do that. That's a potential for the future, but we want to basically get hands-on the tool, more hands-on the tool to start with, and actually see whether that's something that people are actually even wanting. I don't want to spend time on something that people don't even need, and no one's actually requested that yet. So if that is a request, then yeah, we'll definitely look into that. We have been thinking right from the start around the ability of actually providing a test plan as well as the job file, and then the back-end code to run that, which is a lot more work. So, yeah, I mean, we'll get to that bridge when we get to it, I guess. We'll cross that bridge when we get to it.
Exactly. It's kind of one of those things where until there's an actual, proven use case or a need for it, there's no reason to build it. Again, agile development, there's no reason to spend time and money on a feature nobody cares about.
Yeah, but it has been thought about from the beginning, so there's no reason why we can't do that.
Exactly. It was built into your abstractions from the initial standpoint of the architecture. Now, you've kind of mentioned this, that there is some amount of intelligence, but I'm assuming none of this is, hard scripted testing where you're saying, take URL from job file and run X string on it.
Yeah, so the emissary is responsible for actually how to test. We just tell the tester what we want tested, and then the tester spins up the emissary, and then the emissary is responsible for how to go about doing its own business.
Okay, so again, it would be on that end emissary's responsibility to actually write the actual vulnerability test, whereas Purple Team is orchestrating all of these emissaries to run all of these end tests.
Yeah, that's right. Yeah.
Is there any thought process of leveraging something, to use some buzzwords here, artificial intelligence or machine learning to kind of make test plans more efficient or more coverage on code?
Yeah, so that was an idea from day one as well, of having a machine learning module sitting out there that I can't remember exactly whether the orchestrator consulted it or whether each of the testers consulted it. Probably the testers. But the idea is that the specific tests got more focused and got better at basically what they were based on how they've been previously, so on previous test runs and that sort of thing. So the idea is that the orchestrator or the testers consult the ML module and then get back sort of like a refined set of directives.
Okay, so it would almost be like if every single time I ran the application scanner, we got a SQL injection vulnerability and never found any XML issues because we don't actually use XML in the app. Stop testing for XML.
Yeah, that's right.
Okay, that makes sense. And you've kind of mentioned this a little bit, and it's kind of implied by the fact that you did have an ML module concept in there. But what kind of reporting does, OWASP Purple Team actually provide back to users?
So what we've got is we've got the reports from the emissaries. We've got the test outputs from the Cucumber CLI. I think that's it, actually. So at the moment, with 2 test sessions, and one of those test sessions is testing one route and the other test session is testing 2. We're getting back 8 files in our outcomes package. So they get delivered back to the CLI, and then you can open those up and go through the reports, which are from the emissaries, and the actual test outputs, which are from the Cucumber CLI.
Okay, and those reports, what format are they in? I mean, I assume they're not PDF reports, but are they just JSON reports that could be fine-tuned later, or is it something that's coming up in the UI?
Yeah, so those reports are defined in the job file. You can tell the system whether you want an HTML report, a Markdown report, or a JSON report, I think.
Okay, so essentially you could almost get a prepackaged report to hand to the executives, or you could get something that you could put into an in-house tool that you want to format.
Yeah, that's the idea. Yeah.
Okay, and you kind of mentioned this earlier that you had, some statistics and facts, and I assume it's from seeing all of these reports from, actual use cases. Do DAST actually reduce defects? Specifically something like Purple Team. How are you seeing it improve code quality?
Yeah, so there's quite a few different stats and studies around this. One that I looked into quite a while ago when I was writing my book series was a study that was in Steve McConnell's Code Complete book. He had a graph with 3 rows. It had a requirements row, an architecture row, and a construction. I'm mainly focusing on the construction because that's basically, developers are writing code and that's the construction phase. So there's a specific cost for introducing a defect. So we'll call that, 1x. If that defect is not found and fixed until system test time, then it'll cost 10 times the original cost. If it's not found and fixed until post-release, which is basically your penetration testing time, where traditionally a team will get a penetration test done on their application. It'll cost between 10 and 25 times what it would have initially. And I've got some other stats here. So for a 6-month project and a 2-week penetration testing engagement, that'll generally cost you somewhere around $40,000. And what generally happens is only the top 5 critical bugs are fixed, and that generally costs about $24,000. You're up around $64,000 to find and fix 5 criticals, as opposed to spending $100 or $200 on a tool like Purpleteam per month to find and fix almost all of those vulnerabilities.
So when you put it like that, with the fact that you're reducing live time of these code defects, you're increasing fix rates, what is the point of doing an actual penetration test?
Yeah, so the point of the penetration test is that you've got experts that are dying to find gnarly bugs. So penetration testers get quite sort of down when all they're finding is the likes of the OWASP top 10 and simpler sort of defects that developers should have found. So if you give them some actual, some code where they struggle a little bit more, then they're actually going to dive in and they're going to find the more gnarly bugs. So they're still going to find the defects. They're just going to be more gnarly defects.
Okay, so, and I think we kind of discussed this earlier when we talked about, the overlap between penetration testing and DAST and where they kind of fit together. It's that, even though it costs a lot of money, you want to make that money worthwhile and actually find the things that your automated tools aren't going to find.
Yeah.
So would you say that by using something like, OWASP Purpleteam, it's actually going to influence the architecture of your application one way or the other? Is it going to force you away from using lower code level things that are going to have a high rate of defect where you're going to see a huge amount of these issues and push you towards something that it's going to be harder to introduce defects? Or do you think it's not going to change anything at all? Yeah,
well, I would say it would, because, if you're getting bombarded with similar types of defects, then the developers are smart. They're going to basically work out, well, if we introduce this other library or some other technique or something that can stop these similar defects happening all the time, then we should be doing it. And they're going to do it. So, yeah, it will improve the architecture. It's the same as test-driven development, right? Or similar. But test-driven development is not about testing. It's about the actual development. It's about the architecture. It's about creating loosely coupled code that can change easily. Same sort of deal.
Exactly. Leveraging the abstractions and making it easy for you to test portions independently to find some type of defect with functionality or features or what have you. Whereas this is kind of pushing you to not do silly things in your code, essentially.
Yeah.
You probably know were bad and you did it because, it was Friday at 4:00 and you wanted to be done for the day. And on that kind of note, you kind of mentioned the reporting and how that has, some output formats. Have you guys done any integrations for, the chat ops concept, integrating into Slack, or I guess Discord at this point would count, or something more traditional like integrating into Jira or another ticketing system where it's going to create a record of everything that it found automatically and possibly apply some additional automation in that system to assign developers to it?
Yeah, so no, we haven't. Probably because we've basically just been focusing on the core product itself, getting that as good as it can be. But we're definitely open to anything that potentially the community would like to introduce.
Yeah, maybe that's a good addition since you already have the JSON output. Maybe that's another project for someone to work on, is actually integrating that JSON output into these other alerting mechanisms to pull in developers.
Yeah.
But just to kind of close out the show here, is there anything that I missed or didn't bring up so far that you think would be good for developers or software engineers to know about, either the entire dynamic application security testing space or OWASP Purpleteam specifically?
No, I can't really think anything. I think we've done some pretty good coverage on it.
All right, perfect. And what other research are you working on? Are you mainly just working on OWASP Purpleteam, or is there other projects you're working on or books you're working on?
Yeah, so at the moment it's just Purpleteam, and it's been Purpleteam for pretty much the last 3 years. And I started that sort of like when I was getting near towards the end of writing my book series. Yeah.
Okay, and we'll definitely include a link to your book series, since I think it has some helpful overlaps with some of the concepts that we discuss in here in application security as a whole.
Yeah.
All right. Well, Kim, I just wanted to thank you for coming on the show and discussing, how we can leverage things like OWASP, Purpleteam, and dynamic application security testing to improve application security and reduce the code defects.
Yeah. Cheers, Justin.
This is Justin Beyer for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.